Hey everybody, I'm Christian here. In this episode, I'll be discussing the argument from the applicability of mathematics, which is basically a kind of teleological argument about the mathematical order in the universe, arguing that such order is the product of design. Part 1. Mathematical Order. To get a better idea behind the mathematical argument for God's existence, I'm going to use a sort of computer analogy. Consider these two conceivable universes. The first one is a universe akin to a hard drive that has its ones and zeros randomly set, a chaotic and jumbled mess, disorderly and unpredictable behavior at every moment. The second one is a universe akin to a complex computer program with sophisticated mathematical algorithms directing behavior, a universe with consistent mathematical patterns ubiquitously imprinted into nature via physical laws such that it makes physics almost ludicrously successful in precisely predicting behavior. Examples: relativity and quantum mechanics. The physical laws are akin to a program's mathematical algorithms in that behavior is directed in an orderly and predictable fashion. To get a clearer idea of what I mean by Universe 2, consider this equation for the relation between mass, velocity, and kinetic energy. If you find it confusing, note that at speeds well below the speed of light, this equation of classical mechanics gives good enough results, potentially with a very high degree of accuracy and precision, even if not with infinite precision. At any rate, this law of physics provides a sort of mathematical elegance and robust consistency for the universe's behavior, but we can conceive the relation being more like a randomized hard drive, like the relation being this way instead, even behaving differently in different locations, and we can see the relation even being more like a randomized hard drive, in that it changes unpredictably from moment to moment. This is all still describable with math, just like a randomized hard drive is with its randomly set ones and zeros, but doesn't have the same type of robustly consistent mathematical elegance as in the case with what could roughly be described as a mathematical algorithm ubiquitously imprinted into the universe. Our universe operates a lot more like Universe 2 than 1. I could get into fancy philosophical issues of scientific realism versus instrumentalism, but to oversimplify somewhat, physics has been extraordinarily effective in predicting accurate and precise behavior thanks to the universe's elegant mathematical patterns. Albert Einstein wrote this in a letter to Marie Solovine in March of 1952. You find it strange that I consider the comprehensibility of the world, to the extent that we are authorized to speak of such a comprehensibility, as a miracle or as an internal mystery, while a priori one should expect a chaotic world which cannot be grasped by the mind in any way. One could, yes one should, expect the world to be subjected to law only to the extent that we order it through our intelligence. Ordering this kind would be like the alphabetical ordering of the words of a language. By contrast, the kind of order created by Newton's theory of gravitation, for instance, is wholly different. Even if the axioms of the theory are proposed by man, the success of such a project presupposes a high degree of ordering of the objective world, and this could not be expected a priori. That is the miracle of which is being constantly reinforced as our knowledge expands. Notice this part here. A priori, one should expect a chaotic world which cannot be grasped by the mind in any way, which is redolent of my analogy of a randomized computer hard drive, its ones and zeros assigned sporadically with no meaningful pattern. Instead, our universe operates a lot more like Universe 2. Again, physics has been extraordinarily effective in predicting accurate and precise behavior thanks to what could roughly be described as mathematical algorithms ubiquitously imprinted into nature. Or as a reasonable faith God and mathematics video describes it,
Isaac Newton's observations led to his discovery of the law of gravity, a mathematical relationship expressed as a simple equation that enabled us to enter the space age. Mathematics enabled astronomers to pinpoint the location of a previously undiscovered planet, and James Clerk Maxwell used mathematics to predict the existence of radio waves. Albert Einstein, working with theoretical mathematics developed 50 years earlier, formulated his general theory of relativity, a pillar of modern physics. His calculations were later confirmed during a solar eclipse, when Arthur Eddington observed light from distant stars bending around the sun. Then, Peter Higgs used mathematical equations to predict the existence of an elementary particle. It took 48 years, billions of dollars, and millions of man-hours for experimental scientists to finally detect the Higgs boson. How do we explain the astonishing applicability of math to the physical world?
That's an excellent question. Conceivably, this scientific use of math didn't have to be nearly as stunningly effective as we observe. So why is it? For theists, the answer is simple. The universe has this remarkable mathematical order because it was designed. For the atheist, the only viable option for this type of mathematical applicability is just a happy coincidence. But a happy coincidence of this magnitude strikes some people as too coincidental to be very plausible. The aforementioned reasonable faith video presents this mathematical argument for the existence of God.
If God does not exist, the applicability of mathematics is just a happy coincidence. But the applicability of mathematics is not just a happy coincidence. Therefore, God exists.
Part 2, Rationality Rules' video. Stephen Woodford of Rationality Rules responded to the Reasonable Faith video. For sake of time, I'm not going to discuss everything Woodford says. You can get a fuller treatment of Woodford's video in a Caption Christianity video I'll link to in the description below. Instead, I'll focus mostly on the argument from the universe's mathematical order. Woodford quotes various people regarding the explanation for the effectiveness of mathematics.
There are many ways in which naturalists can account for why mathematics applies to the physical world. I've already given you my own, and I'll do so again a little later. But for now, here are just 3 alternative accounts from, in this order, theoretical physicist Sabina Hosenfelder, theoretical physicist Steven Weinberg, and then cognitive linguist and philosopher George Lakoff.
But maybe you do not agree that the effectiveness of mathematics is all that unreasonable.
No, I do not think that it is all that unreasonable that mathematics is effective in the natural sciences. Because what is mathematics about? It is a way to describe patterns, to describe regularities, and that's exactly what we do in the natural sciences.
First of all, how accurate is mathematics in explaining physics?
I don't think mathematics can be ever regarded as an explanation in itself of anything. And this has not always been well understood. Perhaps it's even still controversial. Physical theories aren't the way they are because of principles of mathematics. Principles of mathematics are the language in which we state our physical principles, and they are the intellectual tools we use for calculating the consequences of those principles. But nothing is the way it is because of some mathematical principles.
There is still a mathematics in the world, even if human beings never existed or if brains never existed.
It's not in the world. The world is as it is. Let's take a very simple case. Take a spiral nebula. The logarithmic spiral is not in the nebula. It's in your understanding of the nebula. The marvelous thing about mathematics is that we can create mathematics with our brains that fit phenomena in the world remarkably. It is not a miracle that that's the case, because we have the capacity to see and understand the world, to categorize it in terms of what our brains do, and then we can create a mathematics out of that in a systematic way using what our brains allow us.
None of that really answers the question at hand. For example, yes, we describe regularities in the natural sciences, but conceivably these precise mathematical regularities didn't have to exist, and their existence is exactly what is to be explained in the first place. This is no more an explanation for the consistent mathematical patterns in the universe than saying that the reason opium causes sleepiness is because of its dormitive powers, where dormitive powers just means it has the power to cause sleepiness. In philosophy, this type of pseudo-explanation is called the dormitive principle, where one reiterates the thing to be explained in different words, which potentially gives the illusion of an explanation where none existed. These clips, while they may say true or plausible stuff, don't answer why the universe has the remarkable mathematical structure it has. Because again, the universe conceivably didn't have to be this way. I asked myself, why is it that some people might get hoodwinked into thinking there were explanations where none existed? And I suspect it's the same type of reason red herring maneuvers are sometimes effective. In some cases, if one rebuts a claim by saying something irrelevant but plausibly true and closely related to the topic at hand, that can give the illusion of a refutation where none existed. If you're curious, I talk more about this in vlog episode 8. Similarly, the dormitive principle can give the illusion of an explanation where none exists, at least in part because it sounds plausibly true and is closely related to the matter at hand. It's plausibly true if the thing to be explained obtains. For example, it's true that opium has dormitive powers even if it's not a real explanation. It's closely related because it is, after all, just a reiteration of the thing to be explained in different words. For example, opium having dormitive powers is closely related to the issue at hand even if that's not a real explanation. These first two factors for giving the illusion of an explanation aren't unique to dormitive principles. In Woodford's clips of Weinberg and Lakoff said plausibly true stuff that was closely related to the issue at hand, but didn't really explain why the universe has the type of mathematical order it does. What Weinberg and Lakoff said in these clips here didn't explain why our universe is more like Universe 2 than Universe 1. To be clear, I'm not saying that Hasenfelder, Weinberg, and Lakoff were trying to explain why the universe has the type of mathematical order it does in those clips. However, Woodford seemed to think that what these individuals said in these clips constitute an explanation for said mathematical order. And while these three people may have said plausibly true stuff closely related to the topic at hand, they weren't real explanations for why the universe has its sort of mathematical order. What they said in these clips didn't explain why our universe is more like 2 than 1. What makes dormitive principles particularly insidious is the factor of implication. Explanations typically imply the thing to be explained. For example, suppose the explanation for why Sally's car is wet is because Sally's car was outside and it recently rained heavily. These factors imply that Sally's car will be wet. Similarly, opium having dormitive powers implies that it brings about sleepiness, but is still not a real explanation. So here's one major reason I think dormitive principles give the illusion of an explanation. Explanations typically imply the thing to be explained. However, X can imply Y without X explaining Y. Dormitive principles imply the thing to be explained without being a real explanation. So I think the fact that dormitive principles imply the thing to be explained contributes to the illusion of being a real explanation. Woodford says he himself has an explanation, but what is it?
Second, this answer still doesn't explain why the physical universe has such a stunningly elegant mathematical structure.
At the risk of sounding like a broken record, it's because the laws of the universe are robustly consistent.
We kind of have a dormitive principle here. The Reasonable Faith video referenced Eugene Wigner's paper, The Unreasonable Effectiveness of Mathematics in the Natural Sciences, which had this. It is, as Schrödinger has remarked, a miracle that in spite of the baffling complexity of the world, certain regularities in the events could be discovered. One such regularity, discovered by Galileo, is that two rocks dropped at the same time from the same height reached the ground at the same time. The laws of nature are concerned with such regularities. On that note, it's worth understanding what made science, which used to be called natural philosophy, an attractive field of study before science achieved all the success we now know today. In his book, The Genesis of Science, James Hannam, who earned a PhD in the history of science, wrote, "To understand why science was attractive even before it could demonstrate its remarkable success in explaining the universe, it is necessary to look at things from a medieval point of view. The starting point for all natural philosophy in the Middle Ages was that nature had been created by God. This made it a legitimate area of study because through nature man could learn about its creator. Medieval scholars thought that nature followed the rules that God had ordained for it. Because God was consistent and not capricious, these natural laws were constant and worth scrutinizing. So this theistic belief made a prediction that was empirically verified. At any rate, Woodford's supposed explanation for the data to be explained is that the laws of the universe are robustly consistent. It is true that the laws of the universe are robustly consistent, so much so that we basically have mathematical algorithms ubiquitously imprinted into the universe, making physics almost ludicrously successful in making accurate and precise predictions. But this curious phenomenon is exactly what is to be explained. Reiterating the thing to be explained in different words is a non-answer. It's the equivalent of saying, "because I said so," which makes what he says here especially ironic.
So according to Craig, the answer, mathematics is effective because the universe is relatively consistent, is unsatisfactory, but the answer, mathematics is effective because of God, is somehow perfectly satisfactory. God is a non-answer. It's the equivalent of "because I said so." It not only doesn't answer the how element intrinsic to the why question, but it actively shuts down investigation. It stalls progress and rots the mind.
Ultimately, the only viable alternative to design for why the universe behaves more like this rather than this is that it's just a happy coincidence. A proposed explanation that is actually just a dormitive principle is a non-answer, stalls progress, and rots the mind. To be fair, Woodford does say this in his video.
I can't help but knock the feeling that I'm missing something.
He is, but to be fair to Woodford again, I don't think the argument for mathematics was argued as strongly or as clearly as it could have been in a number of cases, including the video Woodford responded to. I think the argument from the universe's mathematical order becomes clearer when you contrast our universe with the way physical reality conceivably could have been like. That is, conceivably it could have been more like a randomized hard drive and a lot less like software running elegant mathematical algorithms directing everything in a more orderly fashion. Part 3. Better objections. Are there better objections? There are. One is that perhaps the mathematical order in the universe is metaphysically necessary. Basically that it couldn't be otherwise, such that this order would exist even if there were no creator. One point to make is that this type of response, that is this aspect of the universe is metaphysically necessary response, doesn't work in general against conceivable evidence of design in the universe. To illustrate, consider the following scenario. Suppose a meteor shower clearly spelled out on the moon, "There is a cosmic designer. I supernaturally fine-tuned certain parameters of this universe so that this message would appear." Now suppose we do find such fine-tuned parameters, certain physical constants and quantities that can be expressed as numerical values, like a series of multiple dials that are set extremely precisely for the meteor shower text to appear. Suppose also that the parameters are physically necessary, but the physical necessities are nonetheless fine-tuned so that if the values were set outside an extremely narrow range, no meteor shower text would appear. If in this fine-tuned meteor shower scenario someone said this,
maybe these parameters of the universe are metaphysically necessary, so this meteor shower text is not significant evidence of design.
we'd recognize that this person is being irrational, so this aspect of the universe is metaphysically necessary response is too strong. In philosophy terms, it proves too much because it would prove that not even the fine-tuned meteor shower text would constitute significant evidence for design, because maybe it's all metaphysically necessary. But obviously the fine-tuned meteor shower text would be overwhelming evidence for design. One reason I think that this sort of objection doesn't work is because something called epistemic probability, which is the probability of evidential relations, as when a scientist says that the scientific evidence makes the existence of quarks highly probable. If nothing else, one could say that the fine-tuned meteor shower scenario would make the design hypothesis, by which I mean the hypothesis that the universe was a product of design, more epistemically probable. If we think in terms of epistemic probability, the universe more like 2 than 1 makes the design hypothesis more epistemically probable than without that evidence. One way to look at epistemic probability is how surprising certain data would be given a certain hypothesis compared to another hypothesis prior to examining the data. Eugene Wigner and Albert Einstein were both non-theists, and they seemed to think that the universe's structure was quite surprising. Recall that Eugene Wigner wrote, "It is, as Schrödinger has remarked, a miracle that in spite of the baffling complexity of the world, certain regularities in the events could be discovered." In contrast, this type of order in the universe was not at all surprising on the theistic belief of medieval natural philosophers, a theistic belief that was one of the reasons for pursuing science before science demonstrated its remarkable success in explaining the universe. And Albert Einstein wrote, "You find it strange that I consider the comprehensibility of the world, to the extent that we are authorized to speak of such a comprehensibility, as a miracle or as an eternal mystery. Well, a priori one should expect a chaotic world which cannot be grasped by the mind in any way. Again, more like Universe 1 than Universe 2. A universe more like 2 than 1 seems to make the design hypothesis more epistemically probable. Part of the reason for this epistemic probability has to do with conceivability with respect to how the universe could have been like, where something being conceivable just means it can't be ruled out a priori. It's worth remembering that the universe conceivably didn't have to be this way. It could conceivably have been a lot more like 1 than 2. Thinking of it in terms of conceivability rather than metaphysical possibility might help illuminate the nature of the epistemic probability judgment. Here's another objection. Maybe mathematical equations our physics uses don't represent reality exactly. A theory can make accurate predictions without being exactly true. Classical mechanics gives accurate predictions only to a point. There are situations where it didn't work so well and relativity worked better, like in the case of kinetic energy, for example. So maybe the equations of physics we use that are good enough for many practical purposes aren't true with infinite precision. So what can be said of this objection? I think that it does kind of dampen the magic our physics equations have, because maybe it is true that the real world isn't as perfectly neat as those equations represent, even in cases where they do seem correct as far as our instrumental precision is able to test. So the analogy of finding mathematical algorithms imprinted into nature is somewhat rough. Yet while I think this does mitigate the evidential force of this mathematical teleological argument, I don't think it removes it entirely. Even if our physics isn't completely correct and precise yet, physics is still amazingly successful in accurately and precisely describing behavior. It's still remarkable that our universe is far more like Universe 2 than Universe 1, even if it is the case that human physics hasn't reached its final form. Part 4. Conclusion. The argument from the applicability of mathematics is a kind of mathematical teleological argument. I use this computer hard drive analogy to explain a couple conceivable ways the universe could have been like. One is a universe akin to a hard drive that has its ones and zeros randomly set, a chaotic jumbled mess, disorderly and unpredictable behavior at every moment. And another is a universe akin to a mathematical program with elegant mathematical algorithms directing behavior in a far more orderly fashion, making physics almost ludicrously successful in precisely predicting behavior. Our universe is far more like Universe 2 than 1. Upon reflecting the way the universe could conceivably have been like, I think the type of mathematical order we see in the universe is more epistemically likely if the universe were a product of design. Of course, such applicability of mathematics that makes our science so amazingly successful could just be happy coincidence, but I don't think that's the most likely possibility. One way to explain the applicability of mathematics is just to reiterate the thing to be explained, but that doesn't quite work as an adequate explanation to say the least. Another way is to argue that the universe's mathematical order is metaphysically necessary. But I think that the fine-tuned meteor shower scenario illustrates why such explanations for design-like characteristics in the universe don't work in general. A better objection is to note that maybe our current physics isn't completely accurate and precise yet, similar to how classical mechanics was. And while this mitigates the evidential force, by my lights it doesn't come close to removing it entirely. Our universe is still a lot more like universe 2 than 1. If I were to put on my atheist hat, I believe that the applicability of mathematics is just a happy coincidence, but even if it were, as an atheist, I'd concede that a universe being more like universe 2 than 1 does give some non-zero evidential support in favor of design, and reasonable people can disagree about how much support that is. So, how about wrap it up? This is Maverick Christian inviting you to go in peace, serve the Lord, and love logic.
Thanks for watching. If you liked the video, hit the like button. If you want to see more videos, hit subscribe and ring the bell.